As we go on to lesson 3 of chapter 2, we're going to look at linear equations in two variables, and we've been doing that for a while. Here are the objectives, and keeping in mind some of the terminology and formulas we've mentioned before, we'll do a review, and review is good. So to start us off, one of the equations that we've mentioned already is the linear equation in two variables in standard form, which is right here, ax plus by equals c, where the a, b, and c are constants, and both are not 0. Let's move it up. Now, one of the things we want to work on is to see if these equations are in fact linear. And what does that mean? Well, the short form is that the values x and y are only to the first power. Now, sometimes they may have something to the second power, x to the second, x to the third, etc. But it's when you finally simplify these and put them in standard form, then you determine whether or not they are linear. That is, to the first power. Linear means you're going to get a line. So in example 1, they're giving us 6 equations to look at, and we'll do each one by one on the whiteboard. So again, take good notes and be sure you're able to follow the protocol. So there is our first example, a little bit of algebra here, simplifying. 3x. Now, when there's a negative out in front of a parenthesis, the protocol is just remove the parenthesis and change each of the signs, or in a sense, multiply through by a -1. So this becomes a -2, a positive 4y equals x minus y plus 1. Now we want to bring everything over to one side, all of the variables. So again, this is a 1 and there's a 1 that we don't write there. So we're going to subtract 1x from both sides. So this is 2x. Or you transpose that, it becomes a -1x. I'm going to bring this -2 over to this side, where it becomes a +2, and a 1 is a 3. And now I'm going to bring this -1y I should say, over to this side, or add 1 to both sides, 1y. This gives me plus 5y. Now that's in standard form. And notice our exponents are just to the first power. So letter A is, in fact, linear. All right, let's go on and go back and do the next one. So always be sure you've copied the example correctly. I check that and go to the whiteboard. And again, using some basic algebraic skills, I'm going to clear parentheses, so we get 3x. Distribute this. This is plus 2x plus 14 minus 2y. And I'm going to bring this 5x over to this side as a -5x for now. And that equals 0. Now I'm going to collect like terms. I have a 3x and a 2x gives me a 5x. I have a 5x there and a minus 5x there. Okay. Then I have a -2y. And I'm going to bring this 14 over to this side where it becomes a -14. So these just add out. And I'm going to divide both sides by a -2. And I get y equals a -7. Again, we're going to see later this is a horizontal line, and y is to the first power, so this is linear. Let's go back. So we don't get too far from the solutions. There's our solution for A, and we got this. There's our solution for B, and we got this. Let's go on to item letter C. And we can check that we copied it correctly. And let's go to the whiteboard. Now, in a case like this, we want to get rid of fractions. So that protocol was to put brackets, and then we're going to multiply each term by the common denominator, which is what? 15. So 15 times this term, the 3 will cancel out, I'll get a 1 here. This then becomes a 5. 5 times x is 5x. 5 times 2 is 10. Now here, nothing cancels out, so I go 15 times the negative y is a negative 15y. And here, 5 will go into 5 once. 5 will go into 15 3 times. So this side becomes 3y. So much easier when there are no fractions. So again, I want to put my 10 over on this side as a negative 10. And I have a 5x here. I'm going to bring this 3y over as a negative 3y. So this becomes a negative 18y. So again, all of my variables are to the first power. So this is linear as well. Let's go back and check it out. Now, as they did this, they left it as fractions, which is probably okay. Generally speaking, in standard form, we don't have fractions. So again, this would be satisfactory, and getting rid of the fractions would be satisfactory as well. And to show you what kind of guy I am, I'm going to get rid of our fractions here. And our common denominator is still 15. So multiplying this first term by 15, 3 goes into 3 once, 3 goes into 15 5 times, so this becomes 5x. 5 goes into 5 once, 5 goes into 15 3 times. So 3 times a negative 6y is a negative 18y. 3 goes into there once, 3 goes into there 5 times. This becomes a negative 10. Just to show you that the answers are equivalent. All right, let's go on. Now for letter D, that we copied it correctly. Yes, that looks good. So doing the first line of this, clearing fractions, now we want to combine like terms. So this is going to be 3x plus 2 plus y equals y. Well, 3x plus y minus 3. So notice we can subtract a 3x here and a 3x here, which eliminates this. We can subtract a y here and a y here. So looking at this is going to be, I'm going to subtract 2 from this side, so this is 0 equals a negative 5. Is this a true statement? And the answer is no. So here, there are no x's, so this is not linear, it's not really anything, and this doesn't result in a true solution. So there's no solution. And this equation actually, where they were saying it was equal, was in fact not. This is often described as an inconsistency. It's inconsistent. There is no solution for this. All right, let's go back. And just to get verification, looking at D, we see what we've just said. And again, always pause if you need more time. Now in letter E, here we see, in a sense, that this really can't be simplified anymore. We could bring this over to this side, but that wouldn't make much difference. But we see x is to the third power, so this is not linear. Checking out letter F now that we've copied it correctly. Let's go to the whiteboard. So we have x squared minus, now we have to expand this binomial by using that special technique. Square that first term. Multiply these two together, get negative 3x, double it, negative 6x. Square negative 3 gives you a positive 9, and that equals 3y. Now we clear parentheses by just removing the parentheses, changing these signs, or multiplying through by a negative 1. X squared minus x squared plus 6x minus 9 equals 3y. Now notice what happens here. The x's are going to cancel out. Okay, so we can see this is going to end up being linear, and putting this in standard form, this becomes 6x, transpose that, becomes a negative 3y, transpose the 9 becomes a positive 9 on this side, and then going back we see we have this. So this was rather long for one example, but there were many examples to do here. Now here they're introducing something we've done already, and that is the intercepts. And we said to do this, let me make some nice straight lines here. We said a special t-chart would be very useful that we're calling the X and Y intercept t-chart, where the formal way of presenting this would be 0, comma b. This would be your y-intercept, and here is a, comma 0, your x-intercept, and that's where the line would cross the various axes, and that's what they're describing it as here. Now I like the letter B because that's the y-intercept, and the A, they're using slightly different letters. I like what I use. And for this first example, they have an equation in standard form. Let's go to the whiteboard. Here we go. And we did some like this already. So if x is a 0, this is going to be a negative 3. And if y is a 0, this is going to be a 4. So in graphing this, and I should use proper lines for this, since I have a line tool. And you can sketch this as well. 0, negative 3. So 1, 2, 3, a point there. And then 4, 0. 1, 2, 3, 4. Point there, and then there is the graph. And you have found the intercepts using an X and Y intercept t-chart, and you've made the graph. And this is the formal way of writing the intercepts. All right, let's go back, and we can check this out by going down here. is they're going to show us this here. There we go. All right, let's clear this one up and we'll work on the other. The other takes a little bit more work because we have to put it in standard form. So take a moment, let's copy it down and see what happens. So I've checked that I copied it correctly. Let's go to the whiteboard. And let's put it in standard form. 4x minus 3. Now a negative and negative makes this a plus x plus 2y equals 7. Group our like terms. This is 5x plus 2y. I'm going to take this negative 3 here, bring it over to this side where it becomes a positive 3. And I think we did one like this before. Make our little x and y intercept t-chart here. Good little tool. X, y. So if x is 0, y is 5. And if y is 0, x is 2. And now we make our little graph here and plot these. So 0, 5, 1, 2, 3, 4, 5. And then 2, 0, 1, 2. And our graph then will look like that. And let's check it out. And scroll down. And they're saying you can also, of course, use graphing calculators there. Clear that up so you see it better. And there it is. Now, if you do have a TI-84, some other kind of graphing calculator, you can put that in there. And you can also use, if I haven't mentioned already, Desmos.com is a site where they have a free graphing calculator. And you might try that out if you haven't already. Now, here they go into the use of a TI-84 or any other graphing calculator, setting up your field of vision and then the trace function so you can actually pick out your intercepts. Pause again and look this over. Now, we mentioned this a little before, and let's just do a little review. We said equation 5, where it was in the form y equals b, is the equation of a horizontal line, and the slope of all horizontal lines is 0, and b is your y-intercept. Now the vertical line, we said was formula 6, if you're keeping track of the numbers. This was x equals a. This was a vertical line, again, going through the x-intercept at point A. And the slope of all vertical lines is undefined because it would be some value, 5, let's say, over 0. While here it would be 0 over 3 or some number. This, in its simplified form, is 0 divided by any number other than 0 is 0. And here, any value other than 0 divided by 0 is undefined. All right, let's look at some examples. And this is example 3. And as we do these, you can sketch them. So A is 5 x equals 0. We want to put it in the form x equals a for a horizontal line. Divide both sides by 5, and we get x equals 0. So the sketch of this would be a vertical line, and I'm going to change colors, going through our x value of 0, which is the origin. So this actually parallels or is on top of the y-axis, and that's what they're going to show you here. All right, let's go to the next one. Now here, when we solve this, 2x equals, we're going to transpose this -2 to the other side, where it becomes a +2, and this is 5. So we get, divide both sides by 2, we get x equals, if you want, 2.5. And again, in graphing this, putting some points here, there's 1, there's 2, there's 3. So 2.5 would be right about there. And now we can change colors. And I want to get a nice line. That would come out very well. There we go. Again, horizontal. I have a little twist there going through that one. And let's just look at the answers below here. They do a nice job. There we go. Okay, and let's do our third one. So to save a little time, I've written this out. Let's combine like terms now. This is going to be 3x plus 2x is 5x minus 2y. I'm going to bring this 14 over to the other side as a -14. And there's a plus 5y there still. Notice the, I'm sorry, 5x. 5x cancels out, this cancels out. So I'm left with this. I'm going to divide both sides by a -2 now. Careful of the signs. I get y equals 7. Well, this is in the form of y equals b. And to sketch it, it would be a vertical line here. If I can do that, I'm rushing here a little bit. Slow down. Now again, we want to have our little hash marks here. 1, 2, 3, 4, 5, 6, 7. We're going to have a vertical line going through 7. Ooh. And let's check that out here too. And there it is. And that's our last lesson here. Okay, again, lots of stuff. The nice thing I think about these review videos is you can pause it and actually watch it again. Be sure you're being familiar with the protocol so when you do your practice and certify, you have the background and the skill to get the correct answers.